Today we're going to look at graphing straight lines. So the learning goals for today's session are that by the end of this lesson you're going to be able to decide if a point lies on the line of an equation, determine the gradient, x and y intercepts of a linear relationship, and also sketch linear relations. So let's have a look at some properties of linear relations. We can determine if a point is going to be on the line by substituting the values of that point in, the x and the y values of the point, into the linear relation, the equation, and then seeing if that equation is then true. If it's true, then it is on the line. If it's not true, then it isn't on the line. The gradient of a line is a property that describes how steep the line is. If the gradient is very, very large, then it'll be increasing as it goes up, as the diagram is on here. So if the gradient is positive, then it will be increasing and going up from left to right. So this will be a positive gradient here, positive gradient. M is going to be positive. If M, our gradient, is negative, then it's going to be decreasing as we increase the x values. So here M is going to be negative or a gradient is going to be negative for a graph that decreases as it moves across the page from left to right. The gradient, the value for M, will be larger for a steeper graph, higher slope, higher degree of slope, and it's going to be lower for a gentler slope as it goes up. So the intercepts are the points where the graph crosses the x and y axis. So the x-intercept occurs when it crosses the x-axis, and it will be when y is equal to 0. The y-intercept is going to be where the graph crosses the y-axis, and it is going to be when x is equal to 0. So if we have a look at our diagram here, you can see here is the y-intercept. The y-intercept here, the x value, if we have a look, the x value is 0. And if we have a look at the x-intercept here, where it crosses the x-axis, the y value on the y-axis is 0 for that value there. The gradient is given, sorry, I forgot to mention, the gradient is given as rise divided by run. So it's the amount that the graph increases divided by the amount that the graph goes across the x-axis. So another way that you can see the gradient given is it is going to be the change in the y values divided by the change in the x values. So how much the y values are changing divided by how much the x values are changing. And if you have 2 points on your graph, you can if you want to determine the gradient from 2 points on your graph, and those points are x1, y1 and x2, y2, then you can find the change in the y values by subtracting one of the y values away from the other, and divide that by subtracting one of the x values away from the other as well. So you might have seen the gradient represented in any of these ways. It's all the same. The gradient is describing how much it is increasing or decreasing in the y values and how much it's changing in the x values as it goes across. So let's look at a first example. We're going to decide if the point -2, 7 is on the line with the given equations. So if we have a look at 1a to start with, in deciding whether it's on the line, we need to we need to substitute the point into the equation and then see if the equation is then true. So if we write the equation y equals -3x plus 1, if we substitute the values in, the y value is 7 and the x value is -2, then we can see we get 7 equals -3 times -2 is +6 plus 1, so 7 equals 7, tick. Therefore we can say, therefore the point -2, 7 is on the line. Okay, so we've checked it, we substituted in, and we found that it is true. For 1b, we've got 2x plus 2y equals 1. Substitute in our values, x value of -2, so 2 times -2, and our y value is 7. 2 times 7 is equal to 1, so we're left with -4 plus 14 equals 1. -4 plus 14 is 10. 10 is not equal to 1, so therefore our the point -2, 7 is not on the line there. So that point -2, 7 is not on the line of that linear relation. Our second example here is to sketch this value by finding the x and y intercepts. So let's firstly find the x-intercept. So in order to find the x-intercept, what we know about the x-intercept is that it is when y equals 0. So we can say y equals 0, and we can substitute that into our equation. So we've got here 0 is going to be equal to 2x minus 8, because we're substituting in y equals 0, and then we need to just solve that equation. So we can get 8 equals 2x, and that means that x is equal to 4. So that's our x-intercept then is going to be at 4, 0. For our y-intercept, we know x equals 0, and so substituting that into our equation, we'll get y equals 2 times 0 minus 8. So we're going to end up with y equals -8, because 2 times 0 is 0. So that means our y-intercept is equal to x value of 0 and y value of -8. Okay, so we can, probably should have said that over here, x-intercept equals, so showing exactly and communicating exactly what we're giving by that point. So now we need to sketch the graph. So we've got our axes here, we need to plot those points on the graph first. So here we've got the x-axis is at 4, 0, so that's this point here, and our y-axis is at 0, -8. That's going to be this point here. So in order to graph, when we're graphing a straight line, we need to make sure we use a ruler, like I'm not going to do now, but you will be using a ruler. So it's nice and straight, definitely not straight there, but you'll use a ruler. We put arrows on the ends of our graph to show that it continues in both directions. We're not being asked to label the x and y intercepts, but you can do that. We can do that by just putting down here 0, -8, and up here 4, 0. And we should also write the equation of the graph on the graph next to the line to make sure that we've labelled it correctly. Y equals 2x minus 8. So things to remember, please. Here, use a ruler. Use a ruler. Please also remember to label points if you're asked to, but sometimes it's good to just label them anyway as good courtesy, and also label the line. Label the line with the equation, and then ensure you have extended the graph using arrows, with arrows. Okay, my writing gets a bit small down the bottom there, but it says extend the graph with arrows. Okay. Now we can also look at linear relations and linear graphs by putting them in a particular form, which is called gradient-intercept form. It's very easy to read and then very easy to graph from, and it's the general form that we use for most linear graphs, and it's the one that you'll see if you decide to study physics, which you definitely should, looking at the way different relationships interact. the y equals mx plus c is very easy to read off and to be able to graph and to be able to utilize. So that's that y equals mx plus c, where m here, that's going to be the gradient, and c is the what we call the y-intercept, but it's only the y-coordinate of the y-intercept that we need. So remember here we've got, I've mentioned it before, a negative gradient is going to be decreasing as the x values increase. The positive gradient is going to be increasing as the x values increase. So as the x values go up, if we can read from left to right, you can see it increases in the y values. A zero gradient is going to be non-changing in the y values, so you can see that the y value doesn't change. We've also got here a vertical line will have an infinite gradient. It means that with zero change in the x-axis, we've gone and we've increased all the way up. So our gradient for a vertical line is infinite. It's not easy to represent that as in the format of the y equals mx plus c. So we also have some special types of lines that do only have one intercept, and one of those is a horizontal line where it'll be in the format of y equals c. Y equals c. Its intercept will be here, the y-intercept will be at that c point, and that y value does not change. It is equal to c. It is constant. It does not change. We can also have a look at a vertical line. Vertical lines will be in the format of x equals b, and they will cross the x-intercept at the value of b. The x value does not change. It is always always b, regardless of what the y value is. So the y value can be anything, but the x value will always be b. Another line that will only have one intercept is lines that go through the origin. That means that their y-intercept is 0. Okay, so their y-intercept here is 0. That means their c value will be 0. And so that means that if we've got our y equals mx plus c, because that's 0, we're just adding 0. Okay, so that's why we just are left with y equals mx. So that will only have one intercept as well, going straight through the origin. Let's have a look at a couple of examples here. The first one, we're being asked to find the gradient and y-intercept for an equation, and then sketch the graph using that. So our our linear relation that we have is 2x plus 3y equals 3. Now, it's not in the form of y equals mx plus c. In order to get it in that format, we need to make y the subject of the equation. So we need to get y by itself. So let's remove the 2x from both sides, from the left-hand side, from the y by subtracting 2x from both sides, minus 2x plus 3. And we're going to divide both sides by 3. So that will get me with just, or leave me with just y on the left-hand side. Dividing the whole thing on the right-hand side by 3 as well means I need to divide both terms by 3. So it'll be negative 2 over 3x plus 1. Okay, because I've divided both of the terms by 3, divided that whole side by 3. You can't just divide one part of it by 3, you need to divide the whole lot, the whole side by 3. So here we can see, if I was looking at this, y equals mx plus c, I can see that my gradient, m, is equal to negative 2 over 3, and our y-intercept is 1. So I can plot my y-intercept on the graph, because it asks us to sketch the graph. Plot my y-intercept on the graph, c equals 1. Now I can use my gradient to determine a second point on the graph. So it's saying that my gradient is negative 2 over 3. That means for 3 that I move along on the x-axis, I will decrease my y value by 2. Because it's rise over run, how much I've gone up by or down by, divided by how much I've gone along by. So I've gone, you can see here, I go along by 3, my run is 3, and my rise is negative 2, so I go down by 2. So that means I can plot my second point here on the graph, Okay, I don't need to do those arrows. I'm just showing that it's gone along by 3 and down by 2. Okay, and then I can use my ruler to draw a nice straight line all the way through those 2 points. Draw arrows on the end. I can mark those points on the graph. I'm not going to do that because it's just asked me to sketch it. And I'm going to label the graph with the equation as it was given to me. 2x plus 3y equals 3. Okay. I can check that the second point that I've graphed does satisfy the equation by substituting it back in. It's not really necessary if I've completed all of those steps, but I can check it. That point on the graph is -1, sorry, not -1, it's 3, -1. So the x value is 3, the y value is -1. So that's going to be 2 times 3 is 6. 6 plus 3 times -1 is -3, so 6 minus 3 is 3, so it satisfies the equation, which is good. So I've got my graph there, I've extended it out using the arrows, I've labelled it with the equation that I was given, and so that's all complete there. Looking at the last one here, we've got to sketch the following lines. The first one says y equals 2. So that means for whatever x value, y equals 2. So it means that y is going to be equal to here, it's going to be equal to here, it's going to be equal to here. This is going to be a horizontal line with a y-intercept of 2. So that's a graph for y equals 2. I can graph as well the next one, x equals -3. Because all of the x values are going to be -3. Regardless of what y value it is, I'm using my ruler, as you can see, to get x equals -3 labelled on my axes there, showing the arrows extending in either direction. The last one I've got y equals -1/2x. Now I know that the y-intercept for this is going to go straight through the origin, so I can plot that point on the origin. I also know that the gradient is -1/2. So that means if I go along by 2, if I run along by 2, then it goes down by 1 because it's negative. So I go along by 2, down by 1, and I see a second point here using my gradient. Once again, I'll draw my line to go straight through there using a ruler. Joining those 2 dots, and I will label that on my axes, -1/2x. Okay, so you can see, remember those pressure points, we need to make sure we graph 2 points. When we've got our gradient intercept form, we need to make sure we use a ruler when we're drawing our lines, we make sure we label our graph, and we make sure it continues in both directions.